Students, welcome to the science class. In last session, under the chapter of materials, metals and non-metals, we studied about the physical characteristics of the metals and non-metals, isn't it? The characteristics of the metals and the non-metals, the physical characteristics. So in today's session, we are going to discuss the chemical properties of the metals. So, what are the chemical properties of the metals? The chemical properties of the metals are nothing but how they are react with oxygen, how they are react with water, how the metals are react with acids, how the metals are reacts with the bases, how the non-metals are reacts with oxygen, how the non-metals are reacts with water. These are all are nothing but the chemical properties of the metals and the non-metals. Under that, first I am considering reaction of the metals with the oxygen, how the metals are going to be reacted with the oxygen. It is a familiar fact that when you are going to see the iron pillars which are exposed to the air, and moisture, what happens? It will be a rusted. The rusted process, it is nothing but it is a chemical reaction between the oxygen and the water which is present in the environment with the iron metal. Iron metal reacts with the oxygen and the moisture which is present in the environment and makes it will be converted into a rust, isn't it? What it is, how the reaction will be made, so that will be studied now. So any metal that will be reacts with the oxygen, that forms a metal oxide. When any metal will react with oxygen, it forms a metal oxide. I got understood. For example, I am taking here first one example, that is iron. So when iron reacts with oxygen, it makes iron oxide. The brown color, that is rusted powder which is present on the iron rod, that is nothing but the iron oxide or a ferrous oxide. See, when copper reacts with oxygen, it forms cupric oxide. Copper, Cu means the Cu, it means that it symbolizes that it is the copper. When copper reacts with the oxygen, O2 means oxygen, reacts with the oxygen, it will be makes the copper oxide, isn't it? So, but when copper oxide or a copper reacts with the moisture, what it will be forms? It will be forms a green layer on the copper wire or the copper rod. So that is nothing but when a copper reacts with the moisture, it is nothing but the air contains water percentage, oxygen and the carbon dioxide. So moisture, it is nothing but H2O means water, carbon dioxide and oxygen. That is, these are combining these all we call it as a moisture. It means that the moist air has the water percentage, carbon dioxide and oxygen. When copper reacts with the moisture, it forms, that is the carbon, copper carbonate, and also it makes the hydroxide, copper hydroxide, that is COOH twice. OH twice means the hydroxide. So when copper reacts with the moisture, it forms copper hydroxide and a copper carbonate. See, you have to clearly observe here. When copper reacts with the moisture, it forms a green color layer on their surface. So when you are going to see the copper vessels which are present in your home, with which they are reacts with the water, if they are reacts with the oxygen, on the surface of the copper vessels, some green color layer will be present. That is due to the reaction between the water molecule and the oxygen molecule which is present in the environment. What it is? So when any metal here, copper, it is a metal, when any metal reacts with the oxygen, that forms a metal oxide, isn't it? So another one example I am taking here. When aluminium reacts with oxygen, it forms aluminium oxide. See here, when aluminium reacts with oxygen, it forms a thin greenish layer on the aluminium surface. So it will be very helpful that it will be reacts and it will be resist the further oxidation with the air. If you are taking one aluminium rod, you are going to place that aluminium rod in the environment, it will be reacts with the oxygen first time and it makes a green color coating, that is nothing but the aluminium oxide that will be in the green color, that will be present at the rod. So once it will be formed, and in second time, in the next time, on the further time, it will be resist the reaction between the oxygen and the aluminum. So why in electrical poles they are going to use the aluminum wires? Why? Because so that the reason behind that aluminum wires which are present in the electrical poles is nothing but this reaction, that is, once the aluminum wire will be coated with the aluminum oxide, that will be prevents the further oxidation with the further reaction with the oxygen, isn't it? If they are going to present the aluminum wires in the electrical poles. So when they are going to put the aluminum wires in the electrical poles, once it is will be get the green coat will be get present due to the oxidation. Once it will be formed, then it will be resist the further oxidation. Have you got understood? But it will be helpful for the flow of current. I have got understood. If we are going to use iron metal or iron wire in the electrical poles, what happens? It will be continuously reacts with the oxygen and it will be completely destroyed the iron wire due to the rusting process. So therefore, what happens here, in the simple words, once the aluminum wire will be rusted, it doesn't rusted continuously. It will stops the further oxidation with the oxygen. That's why in the electrical poles they are going to use aluminum wires. So in your examination, the one question should be asked on this: give reason why the aluminum wires are used in the electrical poles. Why? Because the aluminum reacts with the oxygen and forms an aluminum oxide layer coated layer on the aluminum wire, and that layer will be further it will defend or it will be restrict the further oxidation with the oxygen, and therefore we are going to use aluminum wire in the electrical poles. And also under one reason here, the aluminum metal is very cheaper metal, that's why we are going to use aluminum. So under one example I am taking here, when magnesium, Mg here means magnesium reacts with the oxygen and also that forms magnesium oxide. So in general, what is here, any metal you are going to take, when it is reacts with the oxygen, it will form some metal oxides. Have you got clear? So when any metal reacts with the oxygen and it forms its metal oxide. Is it clear? So, but the reactivity series or the reactivity action of the metal, it is very different from one another. For example, I am taking here sodium or a potassium. When you have to take, I am telling one activity here. Take a small piece of sodium metal, about a piece of wheat, like a piece of wheat. You have to take a sodium metal which will be kept in a kerosene. You have to take it and you have to wash it through that is filter paper and place it in the cotton. Is it clear? And place it in the air for some times. What happened here? The sodium metal reacts very vigorously with the oxygen. You have to remember here, you have to very careful here. Sodium metal and potassium metals are react so vigorously and it catches the fire when exposed to air. Isn't it? So when you are going to see in the lab, the sodium metals and the potassium metals are kept in the kerosene bottle. Why they are going to kept in the kerosene bottle? Why? Because they are not reacted with the kerosene. But when you are going to put the sodium metal and the potassium metal in air, it will be vigorously react with the oxygen which is present in the air and catches the fire. Therefore, they are going to place the sodium and potassium metals in the kerosene. But so considering these metals compared to the other metals, the iron, copper, they are not so reactive. The rust will be formed, but it takes a long time, isn't it? But in that case, in the sodium and potassium, it reacts very quickly. In the fraction of second, the sodium metal and the potassium metal catches the fire when they are react with the oxygen. So the reactivity of the metals with the oxygen, it is very different from one another. So metals like aluminum and magnesium reacts with oxygen and they form the metal oxides or metal oxide layers on the surfaces. So that's about how the metals will be reacted with the water and so how they are reacted with the oxygen. Now we are going to consider the what they are formed when they are metal oxides reacts with the oxygen. They are formed, the metal reacts with oxygen, they form metal oxides. But when the metal oxides reacts with the water, what they form, what is the reaction behind there? So see here, I am telling one activity here. Collect some rust which is present on the iron rod. Collect some rust which is present on the iron rod, and you have to put that iron rod into small amount of water, about 50 ml of water. Stir it well. You have to stir it well. And now take the blue litmus paper. You have to take the blue litmus paper and the red litmus paper. Check that solution with the help of blue litmus paper and red litmus paper. What happens here when this is the metal oxide, that is the rust, it is nothing but the metal oxide. Metal oxide will be mixed up with the water. When the metal oxide react with the water, what it forms, is it a basic solution or acidic solution? That will be confirmed by using litmus paper. So when you are going to check that solution, that is metal oxide solution, with the help of the red litmus paper or a blue litmus paper, the blue litmus paper doesn't changes here. When you are going to check that solution with the red litmus paper, the color of the red litmus paper turns to blue. What it means, I had say already in last session or in last class. What about that? When the red litmus paper changes to blue, then that solution will be a basic solution. So what here is, any metallic oxide reacts with the water and form the basic solution. Any metallic oxide you can take, the magnesium oxide or the aluminum oxide or the ferrous oxide or the cupric oxide, any metallic oxide you can take. When the metallic oxides reacts with the water and they form the basic solution. How we are going to confirm that basic solution? So I have told one activity here. You have to collect some rust powder of the iron or from the copper, and you have to put that powder into a water, small amount of the water, stir it well, and using the litmus paper you are going to confirm that whether that solution it is a basic solution or it is an acidic solution. But here we get the result that the red litmus paper turns to blue. That means the given solution it is a basic solution. Is it clear? So when any metallic oxide reacts with the water and they form the basic solution. So now I am considering, this is all about the reaction of metals with the oxygen and water. Now I am considering reaction of the non-metals with the oxygen and water. I am taking now as a sulfur. Take a sulfur powder and mix with the water. Take a sulfur powder, mix with the water. Before going to mix with the water, you have to take that sulfur and you have to place in a empty jar with using a 1 spoon. You have to place that sulfur powder in a glass jar which has a cap at one end. So place that sulfur powder in one jar. After some times it reacts with the oxygen which is present in the jar and it will be burned, and that gas will be collected in the glass. Isn't it? That gas will be collected in the glass. You have to place the sulfur in the glass tube in such a way that that gas will be not evolved from that glass tube. It will be collected at the glass. And now pour some water into that glass tube, stir it well, and use that water which is present in the glass. That will be what it is. The sulfur will be oxidized with the help of the oxygen, and that will be converted into a sulfur oxide that will be mixed with the water. You have to check that the sulfur oxide solution with the help of the litmus paper, red litmus paper or the blue litmus paper. What happens here? You are going to see one change here, that is the blue litmus paper turns to red. What it means? So when any non-metals reacts with the oxygen, it forms its oxides, and that further that oxides, when they are going to react with the water, they form the acidic solution. So red litmus, when the red litmus changes to blue, so when the blue litmus changes to red, it indicates that the solution, it is nothing but the acidic solution. So when any non-metal reacts with the oxygen, that's non-metal oxide, and that non-metal oxide when reacts with the water, it forms an acidic solution. So non-metals reacts with the oxygen and water to form acidic solution. This is all about how the metals and non-metals reacts with the oxygen and the water. So this is all about how the metals and the non-metals reacts with oxygen and the water. That is nothing but under the chemical properties of the metals and the non-metals. In the next session, we are going to discuss how the metals and the non-metals reacts with the acids and the bases. That will be discussed in the next session. Thank you.